Hello and welcome to the last week of the Arduino course. Let's start with part 1. In this part, first we will have a recap about everything we have learned so far during the class. Then I will introduce the IR receiver and the remote control in the electronic components section. And lastly, we will see the programming section, how to program the IR receiver. We will take a look over the timing and some C programming concepts. And also, I will show you the hidden goals of this course. The learning objective of this week is to learn how to read an IR signal, to understand the difference between the if statement and the switch statement, to learn how to optimize your code, and to learn the best way to use timing. Let's start with the recap. In week 1, we have introduced the GPIO pins, general purpose input-output pins. We have learned how to read a digital signal and how to write a digital signal. We also have seen the electronic components and terms such as resistors, LEDs, buttons, voltage dividers, current, etc. We have also seen the limitation of the electronic components. You have learned how to build a circuit and how to control it with your code. And lastly, you have learned how to research an issue by researching the debouncing issue of a button. In week 2, you have learned the difference between the analog and the digital signals. You learned how to use a configurable resistor, the potentiometer. You also learned what is the PWM and when to use a PWM signal. You have used a third parties libraries such as the library for the ping sensor and the library for the stepper motor. You have seen the limitation of the Arduino in regards of the current that it can provide in a bin. You also have learned how to control an AC and a DC device using a relay. You have learned how to drive a motor, either by using a direct driving or by using a driver module. You have also learned how to debug your code and use the serial monitor to show information on the screen. You have learned how to read a datasheet and understand the importance of them. And lastly, you have learned how to make comments in your code to make it understandable for you and for others. Now, the hidden goals of this course. In week 1, you have researched a solution and compare it with other solutions. That has been done by researching the debouncing issue. You have learned how to control all the digital input-output components, because all of them works the same way as reading a button or writing to an LED. You have researched the data types in C programming language. You have learned how to find resources to help you with an issue. You also have learned what is a loop, condition, and a variable. And you also can get the syntax by yourself. You have seen the importance and the limitation of the delay by making the volt assignment. And also you have been introduced to events-driven development, when the volt open and the LED lights up. In week 2, you have learned how to control all the analog components, and therefore now you can control the humidity sensor, temperature sensor, you can control the buzzer, LCD, etc. You learned how to understand the documentation of other libraries which are written by other people. You have learned how to combine components in one project when you have done the smart home assignment. You also have learned how to make a parallel-ish controlling of the components when you also have done the assignment of the smart home by controlling the lights while the fan is running. You now understand the requirement of the client. You should have discussed the limitation and the edge cases with the client when you have done the smart home assignment, because there was an issue with the door when you should open the door by using the ping sensor. It could be opened from the outside, but it couldn't be opened from the inside because the sensor is outside. And you have learned the importance of asking questions and taking notes during the class. And finally, you have learned the self-dependency on finding solution and optimizing your code. Now let's move on to the electronic component section. In this section, we will only talk about the IR receiver. When you press a button using your remote control, the encoder in your remote control will encode the signal of that button to be a modulated voltage signal, and then it will be sent to the IR LED. The IR LED at the end of your remote control will then flashes in a certain frequency, which will be the modulated IR signal, and it will be sent to the receiver IR diode. This receiver will read the modulated IR signal in a specific timing and convert it to a binary signal, and then the microcontroller can read it. This process is very time sensitive, and therefore you should be careful when you are using delay or you are using a new Bing sensor library, for example, or any other library where the timing is very crucial. The way you connect it is by connecting the GND and the VCC. The VCC goes to the 5 volts, the GND goes to the ground, and the S is the signal. Now let's see how to program. In this section we will talk about the IR programming, we will talk about the timing, and we will talk about some C programming concepts. So first, before you start making a project with the IR receiver, you should know first the code for each button on your remote control. And for that, you can use this code, and you can also find it online. This code will just read whatever button you press, and it will print the hexadecimal code of the corresponding button on the serial monitor. Once you know the code for each button, you can map that button to be used for a certain action. And you can use any remote control. It doesn't have to be the same remote control that comes with the IR receiver. You can use any remote control laying in your house. Then the code that you would use in your project. First, to use the IR receiver, you need to download the IR remote library from the libraries manager. Then when you want to use the remote control in your project, you include that library. You define the pin that your receiver is connected to. You pass that pin to the library. You define the decoding results as it is defined in the documentation of that library. And here in this example, we have used 2 LEDs to be turned on or off using the remote control. This line will enable the remote control, and those 2 lines will define where the output and the input pins. In the loop, first you will call the library and you will call the decode function. You can use this line as it is. This line means if there is a button pressed using the remote control, then this line will evaluate to be true. If there is nothing pressed, then this will be false. And therefore nothing from the inside here in this if statement will be executed. When a button is pressed, this will be true, and then the next if statement will be checked. If the received value by the IR receiver is exactly the same as this value you have defined in your code, then it will do something. In this example, it will turn on the red LED for 2 seconds and then it will be turned off. And here we are checking another button with another code. If it is pressed, then we are turning the green LED for 2 seconds and then we turn it off. When you use this function in this line, you are saying that you want to remove the result of the decoding of the previous button and make the IR receiver ready for the next button to be pressed. Now let's talk about timing. you have used the delay function, which takes an argument in between two parentheses in milliseconds. This function pauses the program for the amount of time you have defined in between two parentheses. While it is easy to create a blinking LED, for example, with the delay function, and many short sketches, for example, the debouncing problem, the use of the delay function in a sketch has a significant drawback. Because then when you use it, no other reading of sensors, mathematical calculations, or bin manipulation can go on during the delay function. So in effect, it brings most other activities to halt. And therefore, don't use delay unless you really have to. For the alternative approaches to control timing, use millis function. Now this millis function returns the number of milliseconds passed since the Arduino has been powered on. And the return type of this millis function is the unsigned long. You can pull from the millis function until enough time has been elapsed. Pull means you just call it and call it again and again until you see that the enough time has been elapsed. Let's take a look over this example. Now this example will blink an LED using the millis function instead of the delay, and it will print something to the serial monitor. In the first line, we have stored the last time the LED was updated. We have defined where the LED would be connected to. We have made a bool variable and we have assigned a false value to it. This variable will be used to toggle the LED on or off. You can use either bool and it would have the value of false or true, or you can use integer, for example, and you can use 1 or 0, or you can use byte and you can also use 0 and 1. In this line, we have defined a local variable of the type unsigned long, and we have assigned the value that millis function will return. This will store the time since the program has started. Then we are checking if the current mils, which is this variable, minus the previous mils, which is this variable, which is the last time we have updated the LED, if that value is larger than 1000, which means that if 1 second has passed, then we are updating the previous millis to be the same as the current millis, so we can store the current time in a variable. Then we are printing to the serial monitor, and here in this line we are toggling the state of the variable of the LED. We are saying lid state not equal lid state, which means if lid state was true, it would be false. If it was false, it would be true. And then we are writing that value to the LED. You can write to the LED either true or false, or high or low, or 0 or 1. All of those are exactly the same. And here at the end, we used a pause for the whole program for 200 milliseconds, and this pause or this delay will be blocking. So the loop will stop right here for 200 milliseconds and go on then. But using this function, it won't stop. For example, if the millis was, let's say, only 300 milliseconds, then the if statement here would say the current millis, which is 300 milliseconds, minus previous millis, which is 0, and then the final would be 300. Is it larger than 1000? No, it is not. Then this if statement would be skipped, and then the program will stop for 200 milliseconds. And then it will go again back to the millis and check again. It will only turn on the LED or off when the millis has reached the amount of time larger than 1000. Now let's optimize the code. Try to use a proper dentation using the Ctrl-T for auto format. And if you like to format it manually, just add tab before each statement in a scope. A scope begins from the open brace until the closed brace. In this way it will be easier for you to read. Also, don't use magic numbers and magic letters in your code. Here we have previously used 1000 and we have used the text to be printed and we have used 200 to be as a delay. Now then, if you are going to modify your application in the future, it would be hard to go through all of your code to adjust and tweak your code. The best way is to make those as variables. So here we have added a constant variable called time to toggle equal 1000, which is in milliseconds, and we have used it here in the if statement. Then we have used a constant variable of type integer called blocking delay time with the value of 200 milliseconds, and we used it right here in the delay. In this way, all of our variables would be at the top, so when you need to modify something, you can find it very easily. And also here we have defined a constant of the type string. We call it message, and it has the message that it will be shown to the user using the serial monitor. Now let's talk about functions. A function is a block of statements that performs a specific task. Let's say you are writing a C program and you need to perform the same task in your program more than once. In such case, you have two options. Option A is to use the same set of statements every time you want to perform the task, and therefore you would have to copy and paste, which makes your code very messy and very large. Option B is to create a function, and that function will perform the task for you every time by just calling that function whenever you need it. The types of functions, there are a predefined standard or library functions. You have already been using digital write, analog read, and serial print. Those functions are a predefined by the Arduino itself. And you also have been using the library functions, which has been defined by a third party, such as the stepper motor. We used the mymotor.moveTo and we used the mymotor.run. Now those are functions, and inside those functions there are a set of instructions which will eventually do the action for you. Also, another type of the function is the user-defined functions, which you can make them yourself. You would add the function after the loop, but you need to add the definition of that function before the setup. Now, the syntax of a function is first you start with the return type. The return type can be any of the data types, such as integer, double, char, or void. Void means that this function will not return to you an answer. If it is integer, for example, then the function will return an answer which is of the type integer. Then you give it a name. The function name could be anything you like. Then into parentheses you would add the argument lists. Now, the argument lists are kind of input that the function uses. For example, a function which is used to add two integers variables, it will have two integers arguments. So first you give the variable type and then you give the variable name. You can add as many as you wish and separate those by a comma. The body of that function is defined by using the open and the close braces. Inside those you would have the set of statements that would be executed every time you call the name of that function. Now, an example of a function, this is a very basic function. Now this one will add two numbers and it will return to you the result. We have defined a function from the type integer, so the result, it would be of the type integer. We have given it a name called addition, and in between the two parentheses we have given it two variables as the list of arguments. This is the set of instructions that would be executed every time the function is being called. First, we have declared a variable called sum, and this variable is local. It will be deleted when that function reaches the closed brace. Those things in green are just comments. They will not affect anything in the behavior of the function. And here we are adding the value of the argument list and assigning the result to the variable sum. At the end here, we return that variable using the keyword return. Now, a function has to return an answer of the type integer, so we are returning a variable of the type integer. If the function is of the type void, which means it doesn't return any answer, then you don't have to use the return keyword. But if it has to return something, then you must use the return. And after you declare your variable, you write your instructions. This is how you use it. In the loop, we have used it. First, we have made two variables, I and j, with the value of 5 and 2, and we have made a variable called k with no value. After that, we have called the function addition that we have just made. We have passed those two variables as a list of arguments, and we have assigned all of that to k. Now, k will have the result that the addition will return. The addition will take the value of I and j, which is 5 and 2, and goes right here. And then it will do those statements, which will sum those both numbers together. And then it will return the result. That result will be assigned to k. So here, k now has the value of 7. Another thing about optimizing the code, you can group all the functions of a specific task in one file. So let's say you have a project which will do mathematical operations, and it also will control the lighting. Now, the mathematical operations would be a set of functions which will go in one file, and the functions responsible of controlling the lighting, for example, it would go in another file. Now, to make multiple files in one project, first you have your own main project, or create a project if you don't have one already, and make sure to save it. Then you create another project and save it in the same folder with the name of the group tasks or the group of the functions. So either calculations or lights in our example. When you do that, it will be automatically saved inside a folder. So the next thing is to move the file from within the inner folder, and here it's called calculation, move it next to the original project file, which is called in this example demo, and then remove the empty folder. You would get something like this. And then when you open any of those files, you would get multiple tabs on your IDE. Those tabs are the same files. The last thing is delete everything in the calculation file, which means delete the setup, delete the loop, and make it empty, and then start typing your functions. Or if it is easier for you, you can just go to the folder of the original project, create a text file, and then change the extension to .ino. Once you open one of the files, it will be the same result. Now let's take a look over some C programming concepts. On the left side here, we have the usual integer data type that we have been using. So in this example, we are checking if today is Monday or Tuesday or Wednesday, etc. And we need to do something for each day. So in this example, we have defined multiple constant integers with the names of the day of the week, and we have given them values as 0, 1, 2, 3. And then we are using a variable which is called current day, and we are assigning the value 0 as because today is Sunday in this example. Then we are checking if the current day equal 1, which is Monday. We will do something. If it is equal 3, which is Wednesday, we'll do something else. Now, by reading this code, if it is very large code, for example, this would make no sense. If current day equal 1 or current day equal 3, this doesn't really make any sense. Now, the alternative is to use enum data type, and enum is similar to the integer but using names as numbers. This will define your own data type by using the word enum, and then you use whatever word you like. This word would be the name of the data type. Here we have called it day, and now day could be either Sunday, Monday, Tuesday, or Wednesday. They are separated in a comma. Last one doesn't need a comma, and at the end close the brace and add the semicolon. Now you have defined your own data type. So now you have integers, you have string, you have long, and you have day. Now to use a variable of the type day, you just add day and then name your variable, and you can just assign a value from this set of values. Here we say that the current day is Sunday, which is this one is exactly the same as this one, but this is much more readable. And then in the if statements you can say if the current day equal Monday or if the current day equal Wednesday, and both of them are very much understandable. Now let's take a look over the difference between the if statements and the switch statements. Like if statements, switch case controls the flow of programs by allowing programmers to specify different code that should be executed in various conditions. In particular, a switch statement compares the value of a variable to values specified in the case statement. When a case statement is found whose value matches the variable, the code in the case statement is run. The break keyword exits the switch statement. So here in this example, on the left side you see the normal if statement, and on the right hand side you see the switch statement, and we're adding the variable that we are checking in between two parentheses, and we say case Monday, which means if the current day equals Monday, which is more readable and much more useful when you are making an advanced program. Is there any question? Let's move on to the second part of this week. In this part, we will talk about event-driven development. We will see how to analyze a problem, how to design a state machine and what a state machine is, and how to program the solution based on that state machine. So let's start with analyzing a problem. First, we have this problem or a project. The requirements are to make an LED that turns on when you click the turn on button, and it turns off when you click the turn off button, which means we have one LED, two buttons, one of them will turn on the LED and one of them will turn off the LED. Very basic, right? Now, to analyze this problem, we need to ask more questions. Some questions could be relevant, some questions could be not much, such as what color is the LED? Now, this question is not relevant to the programming part, but it could be relevant to the designing of the circuit. And since we are analyzing the problem from a programming perspective, we don't need to bother with this question now. Another question could be how long the button should be pressed. Now, this question is more related to programming, but from the description of the project, it doesn't really matter. So, what kind of questions that we need to ask to analyze the edge cases of the problem? We could ask, what will happen if the LED is turned on and you pressed the turned on button again? Now, you would say logically nothing would happen, right? Because it is already on. But this can affect the program very much, and therefore you have to think about that question beforehand. And similar question would be, what will happen if you press the turn off button while the LED is already turned off? Another question could be, what will happen if you press the two buttons simultaneously? Now let's introduce the state machine. A state machine diagram is a higher level overview of the system, which will make it easier and more understandable. The state machine is a finite state machine, which means that there are a finite number of states, and a state is in which situation the system would be at a certain moment. The state machine also describes the events, and the events are the trigger for the system to change from one state to another. There is also the transition, which is moving from one state to another. And we have the actions, which describes how the system will react and what it will do in a certain state. Now, how to start making a state machine and designing the state machine diagram. The state is represented with a circle. So we have drawn a circle and we have given it a name called state 1, and we have another circle and we have given it the name called state 2. The transition of the state machine is represented with an arrow. Now here we have the transition between the state 1 to state 2, and we have the transition from the state 2 to a state 1. And we have the initial transition, which is the start. When the program just starts, this would be the first state that the program would be in. Event is represented with the text over the transition. So here we have described the event of starting the program. Here we have describing the event that will change or transition from state 1 to state 2 and from state 2 to state 1. And action is represented with text also on the transition or within the state itself. So you can make an action from inside the state itself, or you can make an action while you are transitioning from a state to another, and you add that transition on the arrow itself. Let's go back to the project that we are going to make. We are designing a state machine for a machine that will turn on or off the LED. The LED should be turned off when the button off is pressed, and the LED should be turned on when the button on is pressed. So from a state perspective, the machine only has two states, which is only when the LED is on or when the LED is off. Think of it this way. When you press the button, that is an action, but the result of that action is changing the state of the machine to something else. So here we have two states, one called LED off and one called LED on. And we have added the action within the LED off to turn off the LED, and we have added the action in the LED on state to turn on the LED. Now we have defined that the start of the program would be when the LED is off. So from the moment you start the program, the LED would be off. We have the transition from the off state to the on state only when the on button is pressed, and we have the transition between the on and off only when the off button is pressed. And we have a transition from the state to itself on both of them. This is because we are using a loop in our program. So by default, Arduino uses a loop, which is going to loop over every state of your application if you have defined it and designed it in a correct way. Now let's take this design and improve it a little bit. This is good, but it's not good enough. Now in this version, we have modified the state machine a little bit. We have optimized the program. Now the start is the same, but we have added the action of turning on the LED only during the transition between the off to the state of on. because when it was before in the state itself, it would be executed over and over and over again, and that is waste of resources. And now when you add it to the transition on the button pressed, this will be only executed once. And within the state itself, we have added the function of reading the button itself. So when the LED off, we read the on button, and we don't bother by reading the off button, because it doesn't make any difference if you are already in the LED off state and you have pressed the off button again, then you would be in the same state again. And because we have a loop, that is already happening. So we have removed reading the off button from the off state, and therefore we have optimized the application again. And we also added to read the off button only in the LED on state, so we can check when the off button is pressed. Now this state diagram is only for 2 states, and it's very simple. It could be overwhelming at the beginning, but this will help you very much in the programming. Now you can just take a look over this diagram and see that you have conditions, you have actions, you already know when the transition should happen, and you are almost ready to go. Now let's go for the programming of this solution. We have written this program which will do the same thing as the design of our diagram. First, we have defined an enum of all the states. We call it states, and it has all the states of the system. It has the LED on and the LED off. Then we have made a variable of that enum, or of that data type, and we have assigned LED off as the start state. Here we have used a switch case, which is very useful when you are designing state machines, and it is very useful in embedded systems. We are checking the current state, and we have 2 cases. Those cases are either the LED on or the LED off. Now, in those 2 cases, we have if statements. The if statements only check if the button is pressed or not. Those are the actions on the transition. When that action happens when a button is pressed, those 2 statements are the actual transition. This will change the current state to be the LED on, and then it will break, which means the compiler will go outside the switch statement and therefore outside the loop. When it goes back up, it will check the current state again, and because we have just changed the state to be on, then the compiler will go to wherever the case LED on and execute whatever is inside. And that is also the same when the LED is off. Now, last thing is the assignment. Let's just improve what we have done before. So first we have used the ping sensor to turn on or off the room lights and to control the door. Now just remove the ping sensor because you cannot use it with the remote control. And now instead of using the ping sensor, I would like to use the remote control to open the door using a stepper motor or a servo motor, but then open the door only for 10 seconds. So when you press a button, whatever button you like, you can decide that for yourself. When you press a button on your remote control, the door will open for 10 seconds. After 10 seconds, then the lights and the fan will turn on, which means that the person has just entered the room. Now, when a person is in the room, like I said, turn on the fan, and you can use that as a DC motor with a relay. You already have used that. But now, instead of using a button to change the mode of the LED, use the remote control to determine the modes. So you can also map another button on your remote control to change the modes of that LED. The modes could be changing the color, changing the brightness, or turning the LED off. When you are in the changing of the color mode, you can use the remote control to change the color instead of a potentiometer. And also you can change the brightness with the remote control or turn the LED completely off. Now in this assignment, I would like to ask you to use enums, use the switch statements, and use your own functions in new files. And lastly, if you feel like it, add an extra feature which is unique to you from your own choice. And I would be very much excited to see the result of your application on the Discord channel. Is there any question? This is all that we have to offer today and in this course. Thank you so much for coming and thank you so much for watching. And I wish you had a very pleasant journey with us and you have learned something useful at least. And now I will take all of your questions.